Welcome to the Masterclass on ISO 21434 Cybersecurity. This is the first video of a series of videos on the topic. In this video, I will explain the concept of risk, what a risk analysis entails, and how thinking like a hacker helps in risk assessment when it comes to cybersecurity. First, I would like to point out the distinction between safety and security. Safety is the concept of the system not inflicting harm on its environment. Security is the concept of the environment not inflicting harm on the system. More specifically, harm to the electrical, electronic, digital systems. Now let us discuss some concepts of risk. A general definition of risk is possibility times harm. With possibility, I mean the chance that a harmful event actually happens. With harm, I mean the amount of damage the event causes. Harm can be expressed in many ways, but a workable solution is to express it in monetary loss. In dynamic physical systems, the terminology is a little bit different, and the feature controllability is introduced. That leads to the following definition. Risk is exposure times severity divided by controllability. Exposure means the chance that an event will happen, and the severity is the damage an event may potentially cause. Controllability means a parameter used for threats that may impact safety. However, there are authors that suggest to consider it a cybersecurity control to be used for risk reduction. In automotive, there are 3 specific standards that address risk. ISO 26262 road vehicles functional safety, ISO PAS 21448 safety of the intended functionality, and ISO SAE DIS 21434 road vehicles cybersecurity engineering. The ISO 26262 and ISO 21448 standards address safety, the more or less unintended malfunctioning of the system upon its environment. The ISO 21434 standard addresses cybersecurity, the intended attacks from the environment on the system, with the intention to make the system malfunction. That cybersecurity standard is the overarching topic of this masterclass. In the picture on top, we see hazards. A hazard is an event that causes or has the potential to cause physical harm. For example, in the chemicals and oil industries, any situation that has the potential to cause an explosion or a severe fire. In the automotive industry, a hazard can be any situation that causes a vehicle to crash with another vehicle or the infrastructure, possibly leading to physical harm, injury or loss of life, and other damages. Other damages, such as recalls, damage to the company image, extra work, and so on, are called losses. Malfunctions are system internal causes. Environment hazards or losses are caused by conditions beyond control of the system or the people operating the system. Unintentional misuse is wrong usage of a function due to a lack of understanding of the operational domain or the system. Intentional misuse is wrong usage of a function with the intent to cause the system to malfunction. In order to do a risk assessment for cybersecurity risks, you must think like a hacker. This means thinking the other way around. Not thinking what should the system do, but thinking what should the system not do. In order to learn how to think like a hacker, it helps to understand what their motivation might be. A number of theories have been developed to address this question of motivation. They are the fraud triangle, fraud diamond, and fraud pentagon theories. These theories address motivations like pressure or incentive, opportunity, rationalization, capability, and arrogance. Take some time and look at the following case in Florida. Can you determine what would be the main motivation or motivations of this hacker? You may pause the video and think about this question. When you've read the story, you have done the second thing you can do. Keep an eye on the news. This particular hack was discovered in February 2021. But when you keep track of the news, it is likely that you will find a similar story every week. There are also dedicated websites on this topic. You may want to follow the website of the National Security Agency of your country. They usually have a warning system for serious cyber threats. In this masterclass on cybersecurity in the automotive industry, we focus on only a part of the automotive supply chain. This is the part where the interaction between Tier 1 and original equipment manufacturer, or OEM, happens. Tier 1 suppliers are the suppliers of elaborate subsystems of the type that the OEM buys to implement in the vehicles they build. These OEMs, as they are known, are legally responsible for implementing safety regulations as set by UNITE. Think of safety as inside out, or the system not posing harm to its environment. And security as outside in, or the environment not able to cause harm to the system. Then it is easy to see that security underpins safety. It is impossible to guarantee safety when security cannot be guaranteed. But where to start with cybersecurity? In my experience, organizations and developers often start thinking about security when it becomes clear there is an urgent problem. It would be much better to consider cybersecurity from the start. It prevents immediate and costly repairs. The whole process of cybersecurity starts with the development of security requirements, when the business requirements are formulated. From the business security requirements, the security functional requirements have to be defined. The security functional requirements are then translated into requirements for the hardware and the software. In order to determine the business security requirements, a risk analysis is necessary. For determining safety requirements, HARA, or hazard analysis and risk assessment, is the tool. For security requirements, TARA, or threat analysis and risk assessment, was developed. The ISO 21434 standard is the successor of the SAE J3061 recommended practice. The SAE J3061 recommended practice refers to a number of risk assessment methods: EVITA, Heavens, Octave, TVRA, and some others. 3 of these methods in turn refer to another standard for security requirements, ISO 15408 or Common Criteria. In a threat analysis, you have to consider what threats are realistic for your organization or the product you are going to develop. These threats then have to be translated into security requirements. Many methods use the CIA categories: confidentiality, integrity, availability. These primary security categories have been in use for a long time and are still valid. Some methods have amended the CIA model with items like audit, freshness, and others. But we stick to the classic categories for now. For each category, there are some example questions that can be asked about the system under development. Take, for example, integrity. What happens when the system is compromised due to a hack? This is a major problem because it means the system can no longer be trusted to do what it should do under all circumstances. If the integrity is compromised, the safety of the system can no longer be guaranteed. This is a problem regardless of the fact that an attacker may not have made changes to the system. It is a problem because we cannot know whether the attacker made any changes. Unless a checksum was calculated on the original software beforehand. Then the checksums can be combined to verify whether the software was changed by the attacker. We can conclude for a safety-critical system, integrity is essential. For each question that was asked, an answer should be found. In a TARA, a security goal and a security model are formulated. From this security model, security functional requirements are formulated. When formulating these requirements, it is advised to use an established method. One such method is the common criteria, but also OSA and OWASP have developed methods. These methods are like a library of security functional requirements. The language is quite formal, as you can see in the examples shown. But the advantage is that the hierarchical structure and dependencies are well thought about. This gives some assurance that you will not forget important features and dependencies. Of course, this method is only successful if you've made a good assessment of the environment and translated it to a complete security model. If the security model is not realistic, then this method will not fix that underlying problem. This concludes the video on risk analysis and high-level security requirements. The next video is about assurance. How to design your organization to be robust against cyber attacks. Thank you for watching.